All right, welcome back, algebraists. Did you guys all enjoy the pancake and ice cream party that we started class with today? Yeah. It's good. Glad to hear it. All right, so let's kick in. Last class, we were looking at these. Now, we don't have to rework this exact problem. We'll do another one, but I do want to look at the alternative. For this problem, rather. What we've done is we got all the x's on one side. That's pretty typical approach to working these. We then did what between, I guess they already had a common denominator, so that was nice. We then simplify it down and we see where it takes us, right? Now, there are variations of these problems and different ways that we can go through it. I want to start with a singular example, and if we look at all three of these, we did the same thing. We got all the x's on one side and we solved. Now, if you get the option of dealing with a fraction or not a fraction, which one realistically should you take? Not a fraction is always easier. So we're going to do another type of example, and we're just going to jump right in. It's still a rational equation, so nothing really changes. But I want to look at an alternative approach. It's the same section, different problem. So we have a wonderful alternative approach. Cool, cool. Okay, so looking at this, here's the basic idea. If we wanted to make everything common denominator, Lando zoning out a little bit, but if we wanted to make common denominators everywhere, we could. Now, if there were another way, we should take advantage of that though. So here's like the main point, and we're just going to try to implement this immediately. What if we bust fractions first? Now, I'm going to even leave a little bit of line here and I'm going to leave one blank line so that when we're doing this in our first problem, we can see it happen. And then we'll come back and we'll add something to this. So a little bit of blank space, and let's just try this out. Let's just see what happens. So I want to get a kind of ugly one, and I'm actually going to make one that's worse than what your book does, just so we can see this really working. Cool. So let's try the following. I'm making this problem up, just so you know. With that in mind, do you think it's going to be a nice answer if I just randomly make one up? Maybe. That'd be cool. I kind of doubt it, but let's try it. I want 2 plus x over x minus 3 plus 1 over x equals 2. Now, as we're looking at this, I just want to make sure we can see that there's a couple different approaches. Last class, all the x's are on one side right now, right? Can I add those fractions though? Why? There's no common denominator. Now, could I find a common denominator? Could I give every single piece on both the left and the right that common denominator? Say that again. So I see what the common denominator is going to be. Some of you probably do as well, but if you don't, that's okay. Instead of making everything have a common denominator, it would be so much easier if we just didn't have fractions. How do you undo fractions? To undo a fraction, you multiply, is what Mark said. And I think I heard some other variations of that. If we bust these fractions by multiplying by something specific, we'll be able to save a lot of the fraction work. So let's pretend we're going to find the common denominator, like we are going to find the common denominator, but we're not going to multiply by a bunch of ones. So let's try this. Find the LCD. Now, it's been a little while since we've done this, so I need some help. How do I find the least common denominator? Talk it out with your neighbors, 30 seconds. If you have to look back to 4.4, you can. We did them out of order, so check your numbers. Check back at 4.4. The question at hand right now is, how do we find common denominator? We're going to go 60 seconds, and I'm going to call on somebody random. So everybody should be looking. Talia found it pretty quick. Talia, read me what you found.
The LCD is the LCM, least common multiple of all.
We find the least common multiple of all of these denominators. So here's all that we need to do. If you want me to call it LCM, we can, but I just need to know what it is. What are the two denominators? And really there's a third one, but I'm going to write LCM with the understanding that it's up to you if you want to. The LCD is the least common multiple of the denominator. It gets gross and ugly. But I'm trying to find the least common multiple between, one of them is x minus 3, What's another piece that's downstairs? X, and there's one more. It's a 1, because this is really over 1. Okay, so I can include the 1. It's not going to change anything, but I'll include it. Do any of these 3 pieces factor further? No. So in any of these 3 factorizations, which they're completely factored right now, how many times does x minus 3 show up the most? So the LCD, and I'll switch back to this red color, the LCD must contain 1 x minus 3. What other common factors, and I'll put a check mark there to say we've used it 1 time, others? X, how many times does it show up in any denominator? The most times. Once, bless you. So I get an x, and the other one? Do I really need to write the 1? Why not? Yeah, it doesn't change anything. So this is my common denominator, and I saw it right here, and we could make everything have this denominator. But here's our approach. Rather than making everything have the common denominator, we could just bust the fractions. So here's our second statement. If I wanted to bust all of these fractions down out of fractions, like make them not fractions anymore, we're going to multiply both sides of this equation by what? So we don't want to do the multiply by 1 thing because we don't need to change denominators. I'm just going to give us a statement and we're going to use it. What if we bust these fractions first by multiplying everything? Every single piece by the LCD. Now, we still have to find it. The only thing that's changing is that now instead of making every single piece have x times x minus 3 in the denominator, let's just see what shakes out. So let's try this. I'm going to rewrite this entire first line right here. I'm just going to copy it. And then everything on the left and everything on the right gets multiplied by what? And I'm going to move that one actually. I'll work this way so it fits on the screen. So going this way. What should I multiply everything on the left and the right by? What is the least common denominator we just found? So check it out. We're not going to FOIL it out. We're going to do an x minus 3 and an x. And if I do it on the left, I better do it on the right. So there's the 2 and x minus 3 and x. Now, for this next little piece, it's the most common place to make a mistake. So if you are possibly zoning out right now, I'm going to really encourage you to tune in for, I mean, really all the time, but at least for the next like 30 seconds. I'm going to distribute, but we have to be very careful. When I distribute this whole thing into here, does anything divide out? So you say no. I'm going to write 1 line with the total understanding that I don't want you to really write this after this first time. Do you agree the first thing that we're going to do is it's going to be x minus 3 times x times 2 plus x over x minus 3? Is that what that first distribution we just saw said? As soon as I write it like this, I'm going to ask that question again. Was there anything that's going to divide out? What? These would divide out here, right? Now, I wouldn't cross it out here because we have to distribute to the next term also. But when I do it here, it's super clear, I hope. All of a sudden, what's left right here when these divide out? There's a 2 plus x, and so I have x times 2 plus x. And check it, no denominator anywhere. How about with the second one? Plus, when I distribute this piece into here, realistically, it's going to be x minus 3 times x times 1 over x. Does anything divide out there? The x's. Now, I can see it here, and I think that a lot of you guys probably can see it here, but I don't cross it out because I don't want to leave it behind. So I see that they're gone here, which means that second term no longer has a fraction. It's just x minus 3 times what? Times 1. And I'm going to write times 1 with the understanding that normally I probably wouldn't. And let's finally do the right side. I'm going to rearrange it a little bit just for now so it looks a bit nicer. Instead of saying 2 times x minus 3 times x, for now I'm just going to call it 2x times x minus 3. I just rearranged. Now, what is nicer about the expression that we have in front of us than where we started today? there's no fractions. By multiplying by the common denominator right off the bat, we've eliminated all the fractions that exist. Now, there are a couple things that we need to be mindful of. If we were graphing one of these, for example, we would need to note what divided out and those things because they make us divide by 0. But since all we're doing is solving, we can just kick forward. At this point, it doesn't feel like a big, ugly rational equation anymore. It might not look super nice, but now we're just down to regular old algebra. So any question? Are you sure? Okay, so help me clean this up. When I actually do these multiplications and we start solving it, what do I get here? Can I rearrange it? You're right, whoever said that. Can I rearrange it to be x squared? So not equals, I'm sorry, because there's an equal sign here. So I'm not going to do that. Can I call this x squared plus 2x? I just changed the order, 2x plus x squared. You can keep it, but I already see people erasing, so you do you. Plus what? What comes out of this one? Somebody quietly said plus x minus 3 equals, what do we get here? Two x squared minus 6x. Okay, so I'll show the distribution even though it doesn't really matter. Does this look like something we've done before? If I want to clean it up, because I don't think it looks super nice yet, what's the next thing that we should do if we're trying to solve this equation? Let's combine like terms. Can I just move everything to one side and combine like terms in the same process? Okay. So let's see. I'll take 2 steps. Some of you will take 1 step. I'm fine with that. We have x squared plus, I think it's 3x over here, minus 3 equals 2x squared minus 6x. And I'm just taking small steps. Do you want all the x squareds on the right or all the x squareds and x's and everything on the left? Because what do we need to set this equal to? 0. Do you want the x squareds on the left or right? On the left. Okay. So to get everything on the left, what do I have to subtract from this side then? Minus 2x squared. So I'll do that underneath this. And how do I get rid of this minus 6x? Good. Now, I'm only doing this direction because of what somebody suggested. I would have done it the other way, and we might change it after the fact just to make it a little bit easier on us. But let's just see where we wind up. X squared minus 2x squared. Negative x squared plus 3x plus 6x. 9x minus 3 is equal to what? 0. Now, first big question. We haven't done anything wrong. I would have subtracted x squared and made everything on the right. How come? X squared would have been positive. Now, why would I care that it's positive x squared instead of negative x squared? There's a shortcut available. So we have 2 options right here. We can either multiply both sides by something to make it a positive x squared, or we can just factor it with grouping. So we could have just moved it to the other side. That's what I would have done initially. But if I multiply both sides by some number, I should be able to change it. Let's multiply both sides by negative 1. In doing so, and this is only to make our factoring easier, not a requirement, but if you don't want to use grouping, this is our option. By doing this, we wind up with x squared minus 9x plus 3 equals 0. And in the end, I don't know that it really mattered because, again, I made up this problem. Anybody tell me factors of 3 that add up to 9? Oh, boy. So I can't factor it anyway. Not by shortcut. I can't group it. Ooh, what was that? There's no factoring technique available, so I'll make a note here. No easy factoring. Implies quadratic. And I'm going to say quadratic formula because it didn't sound like it was going to. Okay. Anybody remember the quadratic formula off the top of your head? So let me get one person. Angel, you've spoken a lot today, which I appreciate. Michael, I think you've said something. Anybody but Angel, Michael, Sonny? I thought you were the one volunteering. Sorry.
Negative b minus, plus or minus.
So let's just work it out here. What's negative b going to be in our problem?
I think it would be 9, negative 9.
So negative 9 is b right now, right? So what's negative 9? Good. 9 plus or minus the square root of which is 81, because that's 9 squared, or negative 9 squared, minus 4 times 1 times 3, that's AC, bless you, all over 2a, which is 2 times 1. Bless you. Okay, now we're one step away. You're just going to help me clean it up a skosh. X equals 9 plus or minus the square root of, that's 81 minus how much? So 81 minus 12, I think, is 79, which feels like a prime number to me. All over 2. And look at that. We have a super ugly answer right now. We should check this, but I am going to be honest. In the interest of time, and the fact that I know I won't give you super ugly answers like this on the test or quiz, instead of getting this super ugly decimal and approximating it to check it, we are just going to say we should check it, but we're not going to do it with the super ugly numbers, only because of time. Okay. Is this easier than making common denominators? Easier might not be the right word. It's definitely more efficient. If you would rather go through and common denominator everything, can you? For sure. You're going to wind up getting the same answers, but you're going to spend way more time on it. Okay. This technique is super convenient to have. Now, I really wanted to do rational inequalities. We'll save that for pre-calc, though. I want you guys to do one more for me. And I guess I should probably go back here. I'm going to go ahead and say 60 seconds. I'm almost certain that at some point in here, almost every person had a question that didn't get addressed. 60 seconds maximum. I want you, before we do the next one, with your neighbor, discuss, find where the questions are that you guys can't clear up amongst yourselves. Talk it out. 60 seconds. Okay. So the good news is that the problem that we just did together is significantly harder than the one that I'm going to make you guys do on the homework or independently. I want you guys to work through one more for me just to get a good feel to verify that we're okay with these. And let's check it. I want you guys to help me with the following. Now, I'm going to suggest you do it the way that we just did it, but it's not the only option. But you should. So here we go. I have x plus 6 over x minus 3. And I want to know, when is this equal to 2x over x minus 3? Why is this problem easier? What is the common denominator? So immediately, what should you multiply both sides by? X minus 3. Just bust the fractions from the get-go. We don't have to deal with them. I'm going to give you guys like a little bit of a head start. I'll be walking around, so if you're not quite sure what to do, cool. If you're watching this video from home, go ahead and pause it, try to work it. And when we resume, you won't hear it talked through, but you will see the detailed work for this problem. When we get to a quiz or a test, if you get to this point and you just say, yep, I'm done, and you don't check them and one of them is extraneous, I'm going to count your whole solution wrong. Like just the actual x equals part. Can't include them. So we need to check. So here we go. Check. And we'll just do it in blue. I'm going to put my original function back in just so I can see it. There it is. I need to see if either of these break my function. Can you tell me if either of them do? I have an issue with x equals 3. Why? If I pick x equals 3, it makes me divide by 0. So can I use this? No, get out of here. You're garbage. That is, makes me divide by 0. There's a real word for it. Good. Extraneous. We omit or get rid of that answer. Let's check the other one, though. Let's see if 2 works. If I plug in a 2 for every x, I'm going to claim that 2 plus 6 over negative 1, and I'm just plugging in a 2 minus 3, equals 4 over negative 1. Is 2 minus 6 equal to negative 4? Hey, I'm good. I'm confident with this answer. Now I'm there. We have our answers. X is 2. Only one that works. The other one mathematically works, but it makes us divide by 0, so it doesn't really work. That extraneous, it's a weird idea. Cool. Having a real hard time gauging just from the looks on your faces. Thumbs up says, yep, I'm good. I can do these. Thumbs down says, uh-oh. Anywhere in between. You don't have to broadcast it to everybody. I don't see tears running down anybody's face right now, so that's a good sign. Cool. All right, we have 20 minutes. And that's the conclusion of our chapter. Yo.
So when we find the roots, do we include trees or no?
Like for our actual answer?
Yeah.
Nope. So this cross out is what I'm hoping to see on your page. That's a good question.
So it'd be X.
The only answer, and we can rewrite it if you'd like, and that's a good point, Sonny. The only answer that we have here is the set of x, and I'm okay with just saying x equals 2 as our only answer. Cool. Is that more clear? Awesome. All right. Sweet. So here's the good news. Do we want to graph one of these two? Okay. You really? Okay. I'm fine with that. Sweet. So I'm going to have a short-ish assignment for you guys. Ooh. There's one type of problem that we did not do together, but I know for a fact that you see pretty regularly in like 8th grade algebra stuff. We did not talk about it, but I want you to try the following. So I'll put it on Google Classroom instead. All right. So let's see, we're first hour algebra. Happy February, by the way. Did Puxatani see his shadow this morning? Yeah.
What's his name?
Puxatani Phil.
Why is it his name?
Because he lives in Puxatani, Pennsylvania
Is that always his name?
for the last 100-something years.
Phil?
Philip. Do you guys know about Groundhog's Day stuff?
We don't usually.
Oh my gosh, it's the weirdest thing ever. So there's a little town on the East Coast, Puxatawny, Pennsylvania. And here there's a lineage of these magic groundhogs, which are like gophers or ground squirrels, that every year on February 2nd, they coax this one singular groundhog who's not been the same one for hundreds of years. They just keep naming the new ones the same name, just for the record. And if he comes out, he has two options. When he comes out of his hole, he either looks down at the ground and sees his shadow right away, or he doesn't. And apparently, and this is not true to my knowledge, but what he sees dictates whether there are 6 more weeks of winter or whether winter's done. It's definitely 6. So what do you guys think? Is winter over? We're in spring at this point? No, I have no idea what Phil did, but I will fill you guys in with that here shortly. Unintended. Okay. It varies from year to year. Your homework this evening, you guys will find waiting for you lovingly on, let's see, homework 4.5, page 218. And I want you guys to do problems 15 through 23 odd. Now, I'm going to stress something real quick. Number 19 is in this list, just so you guys are aware. And I'm not even going to put this here, but I'm going to make this comment. If I show you number 19, do you guys remember doing the problems that said if it takes Johnny an hour to paint a room and it takes Deborah 3 hours to paint a room, how long will it take them to paint a room together? You guys probably remember problems like that. My guess is an 8th grade problem. For this, you get to do one of those problems because it's exactly what we're doing, but I want to stress it here. If we didn't do this problem about Paige and Malia, which they're each doing something, and you're not sure how to set it up, where would you look in your textbook? Example 2. If it takes me 6 hours to paint a room, I'll just tell you, in 1 hour, I can paint 1/6 of it. That is the key to doing these problems. Sweet. I'm going to give you guys time to work. While you're working, I'm going to see if old Puxatani Phil saw this. And just in case somebody is at home and you don't have your book and none of your classmates are willing to send you a picture of the assignment, I will slow scroll my way through it so it's online for you. 19 through 23. 15 through 23 got me good. Cool. All right, you guys do it to it. We got about 15 minutes. I will see what's up with Phil.